Hello guys, today we are finding out the calculation behind Hosmer and Lemeshow goodness of fit test. This test is used as a calibration test for logistic regression model. Calibration refers to how well predicted probabilities match actual observed outcome. Today we will see how Hosmer and Lemeshow test works. Here we have a SPSS data. It is a fictitious data for patients in hospitals. We have 7 clinical features and 1 outcome feature, which is mortality. Here, 1 stands for mortality and 0 stands for no mortality or survival. Here we are trying to predict mortality with the help of clinical features. Since our outcome is binary, we will use binary logistic regressions. So to conduct binary logistic regression analysis. For that, we will go to Analyze, Regressions, Binary Logistics. We will put clinical features as predictors and mortality as dependent or target variable. So we will put back clinical features back as a dependent variable and mortality as a dependent variable and clinical feature as a predictors. We will go to options and check classifications plot. We will also check Hosmer and Lemeshow goodness of fit test, which is our topic of discussion today. Let's also check confidence interval for exponential b. Then we continue and then OK. Here we have in logistic regression output, we have no interest in block 0, so we will go to block 1 and see that model is significant. I have talked about calculations of likelihood ratio test and negative to log likelihood in my previous video. There I have talked about how these tests are used to assess significance of a model. Please check earlier videos for good explanations of this test. Here we have a result of Hosmer and Lemeshow test. We see that the significance of Hosmer and Lemeshow test is 0.494. The null hypothesis for Hosmer and Lemeshow test is that the observed probability don't match predicted probabilities. Since p-value is 0.494, the null hypothesis is rejected and we conclude that predicted probability align with observed probabilities, meaning good calibrations. Here we also have a contingency table for Hosmer and Lemeshow test. We will discuss briefly how this table is generated and how significance for Hosmer and Lemeshow test is generated. For that, we go back to SPSS data and we will do logistic regression analysis again. So that we go to regressions, binary logistics. Here we have dependent and independent cell filled from previous analysis. We are good with these entries. But this time we will also go to Save button and check predicted probabilities. Then we continue and go to options. We have box checked from previous analysis and that is good enough for us. We continue and OK. We go back to species data and see that new column for predicted probabilities as pre1 has been generated. We put pre1 in ascending order. Now let's copy the whole data with Control A and we select copy with variable names. We paste the data in a Google Sheet. We have 174 observations which we divide into 10 equal parts. Since 174 cannot be divided into 10 equal parts, first 9 group will contain 17 observations and last one group will contain 21 observations. Let's introduce a new column and name it observed number of mortality. Next, we create another column and name it expected probability of mortality. Similarly, let's get another column and name it expected number of mortality. Then we go on to create another column and name it observed number of survival. We create another column and name it expected probability of survival. And lastly, we create a last column and name it expected number of survival. We are finally done with adding columns. Let's first calculate the observed number of mortality for first 17 observations, which is equal to count if we select the range up to row 17 for a column mortality and select and we put is equal to 0 is equal to 1 and we hit enter. So 5 is the observed number of mortality for these first 17 observations. Now let's calculate the average of first 17 predicted probabilities in this new cell, which is equal to sum of first 17 predicted probabilities which range from I2 to I15, sorry that is I18, and then we divide the total number of observations by 17 to get an average and we get a result of 16.23%. This is an expected mortality of first 17 observations. So let's calculate the expected number of mortality for first 17 observations in new cell, which is equal to expected mortality times number of observation, which is 17, and the result is 2.759. This is the expected number of mortality for first 17 observations. We see that the observed number of mortality, which is 5, and expected mortality, which is 2.759, is same as Hosmer and Lemeshow test in SPSS output. So we have successfully calculated the observations for first row. Now we will similarly calculate the expected probability of survival and expected number of survival in Google Sheet. Similarly, now calculate the observed number of survival in a Google Sheet, which is equal to 17 minus this cell, which is the observed number of mortality, and the result is 12. Now let's calculate expected probability of survival, which is equal to 1 minus expected probability of mortality. So the result is different. When we do it, it's equal to 1 minus expected probability of mortality, and we get a result of 0.837, which is 83.8%. Now we calculate expected number of survival, which is equal to 17 times the expected probability of survival. So expected number of survival is 14.24, and the observed number of survival is 12 for first 17 observations. Now we go to species output and see that this expected number of 14.24 and observed number of 12 is same as species output and same in Google Sheet. So we will do this for all groups. First 9 groups will have 17 observations, and last one group will have 21 observations. We will complete the contingency table for Hosmer and Lemeshow test as mentioned above. After completing the first row, it is very easy to calculate the expected number of mortality for all the groups. I have copied this table to Google Sheet. So in this Google Sheet, I have same contingency table for Hosmer and Lemeshow test. Let's insert new column right of the expected mortality, which is survival. So on the right, we insert a chi-square statistic, which is equal to observed survival minus expected survival, which is whole squared, and divided by expected survival, and we hit enter to get the chi-square statistics. We fill all the row to get the chi-square statistics for remaining rows. Similarly, we insert new column to right of expected mortality. Here again we calculate a chi-square statistic, which is equal to observed minus expected mortality divided by expected mortality after squaring the denominator. We fill the whole row to get the chi-square statistics. Now let's calculate overall chi-square statistics. But before doing that, we need to sum the chi-square statistics from the two new columns we generated. We sum these two rows to get the chi-square statistics. Now we can finally calculate the chi-square statistics by summing these two cells and getting the overall chi-square statistics. We also see that degree of freedom here is number of rows, which is 10, minus these two columns for mortality and survival, and 10 minus 2 is 8. We go back to species and output and see that chi-square statistics for Hosmer and Lemeshow test is 7.4, which is same in Google Sheet and species output. We can also calculate the significance as a p-value. For that, we go to a website which is startrek.com. We will fill the degree of freedom as 8 and the chi-square value as 7.4, which we calculated, and also we add this value in SPSS output. We'll go to calculate button and get a p-value of 0.494. This p-value of 494 is same as the p-value in Hosmer and Lemeshow test. Finally, I'd like to conclude my video with a note on significance. If a test has high p-value, that is more than 0.05, it suggests that the predicted probabilities align well with observed probabilities, meaning good calibration. If p-value is less than 0.05, this indicates poor calibrations, meaning the model's predicted probability do not match actual outcome as well. So we complete this video. Please like and subscribe. Thank you.